I'm still looking for a solution how to insulate the connection wires going from the stem to the digits. I need to insulate them against glowing because if I don't do this, they would catch the parasitic glow and they would glow together with the digits, which is not really nice. Under the last video I got really a lot of helpful comments, thank you very much. There were a lot of things which I will at least try because they are really interesting. For example, fiberglass sheathing and a lot of other things, many chemicals which I can coat on the wires, and in some way they would always be difficult to make in a bigger scale. Let's say in thousands of pieces it would be really difficult to make. But I want to try them because we can use them at least for some prototyping and other stuff. But there was one thing, there was mentioned a black oxide on a metal. I didn't know actually what, like I never heard black oxide, what does this mean? So I googled it, and it's a process when you take a steel part, you put it into a caustic soda, 150 degrees C. During this process there is a black oxide, like a iron oxide, formed on the surface of the metal. This process might be good, but actually there are several problems for us. It's really dangerous. There are several nasty chemicals involved in this process, and I don't want really to set up this process here, because once this is set up I need to delegate it to someone else, and I don't want our people to work with this kind of thing. So I was thinking more in this direction, and when I was reading about this black oxide, I found some chemicals which can be coated over copper. And from this idea I realized that we actually have here oxidized wire. We normally work with it. It's something called dumet wire. This wire is used for sealing into soft glass. You can know it from light bulbs or anything. Like always when you see a wire going through the glass and it has a pink color, it's most likely this wire. It's called dumet wire. It's a nickel iron core coated with copper. And this copper is oxidized like in a controlled way. It must have the right composition of the oxide, and to protect it from like growing more of this oxide and during the sealing, because there is a lot of heat involved, it's coated with borax. And I got this idea to use this wire. Potential problem is borax here. I'm not sure if it is really resistant to vacuum, and if I can, if it can exist in a plasma, maybe decompose somehow. So we need to try. Borax is one of the parts which is mixed with other chemicals to create glass. So it should behave like kind of like a glass, and glass is super good for vacuum. Also, the idea is that dumet wire is used for manufacture of high vacuum and ultra high vacuum tubes. I think that if the borax would mean any danger for vacuum, they would not use it for stems for this type of tubes, because they can for sure clean it, but I'm sure there is always some little residue on the wire going to the vacuum part of the tube. So I don't think they would be able to set up a 100% reliable way how to clean the borax before using the stems made with the dumet for the high vacuum tubes in the mass manufacture. So for this reason I think the borax doesn't mean any danger, or it's not harmful for vacuum, so it would not spoil the gas in our tubes. But I need to test this. First test what I will do is about vapor pressure. I want to make sure that borax has low enough vapor pressure, because if the vapor pressure is too high, it could evaporate or decompose in the nixie tube, and it would spoil the gas. And the biggest risk here that this would happen slowly, and it would poison the gas inside over let's say a year or so. So I'm going to make a test. I will make It works like this. Here is the borated wire, here will be high vacuum, and here we have a hot ion vacuum gauge which will analyze the vacuum inside. The reason why I'm using something like this is that all this I can bake out. I can put this into the bakeout oven while it's under vacuum, and I can seal it while this is properly outgassed. So this will tell us in, let's say, several weeks whether the borax has low enough vapor pressure, because if I can measure here still high vacuum while this is while the borax is inside, I know that it has low vapor pressure and it doesn't release any gases inside this system. Here I'm inserting roughly 20 times higher amount of the dumet wire than we will actually use in the H-tube. The reason for such high amount of the wire is that I want to avoid the possibility that the outgassing will be very low and it will stay under resolution of our test. So with the higher volume, I'm scaling up the potential outgassing and making it easier for us to detect the outgassing. Before inserting the wires, I clean the tube with water, so there are still some water drops remaining in the tube. And this is interesting, the borax is water soluble, so there is some small amount of borax being dissolved right now, and later we will see some residues from the borax. The tube is being pumped, so in the meantime let's look at the old apparatus. So this thing is the vacuum gauge controller, so I will connect it here and then I will turn on the filament and it will be able to measure the vacuum inside. So this is grit and this is filament. Okay. So this is the power, this is filament, so error. Okay, maybe I need to fix the cabling, I'm not sure. I haven't been using this for a while. Yes, so here in this tube is still 3.7 times 10 to the minus 5 torr, so still high vacuum, that's wonderful. So let's check the other one. This is how it looks when you have all second-hand equipment with missing parts, so you need to make the connectors and everything yourself, and then it breaks and so one day I hope I will be buying only new stuff, but now we have to be grateful for a used one. Also 3.1 times 10 to the minus 5, so also in 10 to the minus 5 range. Here is another apparatus I made in 2016, and this one was also to test the vapor pressure of the parts that we use, like all the coatings, all the like raw material, if I can use it. So let's try this one. I just got a small shock because I didn't turn it off. So still 10 to the minus 5 range. So still vacuum inside, that's good. After 4 years. The tube is already pumped and it is still hot. Notice the black color of the dumet wire. When you make a dumet seal and the glass is still hot, it has this dark color. So when it cools down, it will get back to the normal pink color. And here you can see the stains which were left after drying the drops with dissolved borax. What is weird, borax is normally white crystalline substance, so it should be white, but you can see that it has the same color as the wire. So I think that part of the copper oxide is dissolved into the borax, and then together with the borax it was dissolved in the water. So this is something which can potentially change the vapor pressure, and for this reason we need to do these tests. Most of the gases are removed during the bakeout process. Here I'm heating up the grid, and during this process there is additional gas removed from inside the metal and from the surface. There are still oxides, so these oxides are broken down into pieces and evacuated. And also this heats up the surrounding parts like the filament and the holders to higher temperature, and all this helps to get better pressure in the end. You can see a white deposit layer on the glass. This was deposited during the previous use of this gauge. And now I'm trying with a torch to heat it up to higher temperature than was the bakeout temperature to help more gases to leave this layer. Actually, this was a mistake. I shouldn't do it because I'm used to heat like this the borosilicate glass, but this particular glass is leaded and it has lower melting temperature. As you can see, the glass got soft and deformed by the vacuum inside, and this will result into problems later, you will see. Okay, so we are at 10 to minus 6 already. So this means that the bakeout is finished. And last thing to bake out is the filament. So I will now turn on the filament. Okay, I can turn off the grid degassing. And as it cools down, also the vacuum goes down. You can see 10 to minus 4. We have 10 to minus 6 in the system and 10 to minus 4 in this gauge. This is normal. There is a pressure increase because the gas needs to go through this tubing, so there is some pressure loss or increase actually. The tube cooled down and we are at the 10 to minus 6 range, just like in our system. The pumping is now very slow, so I will finish it. I will seal off the tube. So now we need to let it sit for a while so that the gauge can settle down, and then we can write down the final vacuum. Right now there is 4 times 10 to minus 5, and we will see in a few weeks if the vacuum goes up or down. It should stay roughly at the same level. There might be some outgassing, but it should stay at the same level. The next day I found the tube cracked. I heated it too much, leaving stress in the glass, but from what we already saw in this experiment, I think that this borated dumet wire will be good for our use. So I will fix this tube and I will do some more experiments, and this will be shown in the next video. thank you for watching and for all the ideas you are putting under the videos. I'm really grateful for this.